Greetings to you, welcome to Physics with Ben. In today's video, we want to look at calculations on galvanometer conversion. Don't forget to subscribe and share this video to those that need it. Kindly watch my video on how to convert a galvanometer into a voltmeter, a galvanometer into an ammeter. If you don't watch that video, you won't be able to understand what we are doing in today's video. So we want to quickly go straight to the point why we're here today. This is the textbook I am using. Get your calculator set and let's begin. In the other video, I said that a quick recap. I said that if you intend to convert a galvanometer into an ammeter, you have to connect the galvanometer in parallel with a very low resistance wire called a shunt. And if you do that, you'll be able to do that. And then how to convert a galvanometer into a voltmeter. I said in that video that if you want to convert a galvanometer into a voltmeter, you need to connect the galvanometer you need to connect the galvanometer in series with a very high resistance wire called the multiplier. A galvanometer is a very sensitive electrical device that is used in measuring currents in milliamps. So straight to the point. New School Physics, question number 4 and exercise 4, page 408 to page 409. I want to solve question number 18. Question number 18. It reads, a galvanometer of internal resistance 100 ohm gives a full-scale deflection for a current of 10 milliamps, full stop. Calculate the values of the resistance necessary to convert the galvanometer to I, a voltmeter reading up to 5 volts, II, an ammeter reading up to 10 amps. Solution. The parameters in the equation are as follows. Let's call this Rg. The internal resistance of the galvanometer Rg is given to be 100 ohm. And then the galvanometer gives a full scale deflection. By full scale deflection, we mean that the galvanometer reads clockwise. This way, maybe on 35, that is it. Where the current of 10 milliamps was passed through it. So we say that the current of the galvanometer is given to be 10 milliamps, and this is the same thing as 10 times 10 raised to negative 3 amps. Now, they ask us to calculate the values of the resistances that will convert the galvanometer. That is the resistance I, that is Rm, that will convert the galvanometer, that is Rm dot dot I, that will convert the galvanometer to read Rm that will convert the galvanometer into a voltmeter reading up to what? The voltmeter reading up to 5 volts. Yes. And then R shunt that will convert the galvanometer into ammeter, into an ammeter reading up to 10 amps. That is the equation. So this is I, and this is IR of the equation. So we are going to start solving straight away. Before we solve that, we want to sketch the diagram for the equation. If a galvanometer is to be converted into a voltmeter that will read up to this, then we'll have to connect the galvanometer in series with a very high resistance wire called the multiplier. This is the diagram. So this is, let me draw it proper. So this is the high resistance wire, and this is the galvanometer. It gives a full scale deflection, meaning to the right hand side, and this is, let's call this our terminal A, and let's call this our terminal B. So we extend this line down, extend this line down, and then we join it here. So the current we come in from this end, the current will come from this end, we go in here, we come down, we go this way, we come this way, we come here, we go up here, and then we bust out here. So if you remember in the other video, I told you that when resistors, this is Rn, resistance of across the multiplier. That is resistance of the multiplier Rn, and this is internal resistance of the galvanometer. Then this is the current I total entering into the circuit, and this is the current. This section, this is the current for the multiplier, and this is the current for the galvanometer. I told us in the other video that if resistors are in series, you have the same current flowing through them. However, you have different voltage across the resistor. So this is the voltage across from this point down to this point. This is the voltage across the multiplier. And then from here back to this place, this is the voltage across the galvanometer, Vg. So with this condition, we are good to go. Now from Ohm's law, we know that V is equal to what? IR. And then from this expression, we know that our IT is equal to IM is equal to IG. And the current into the galvanometer is 10 milliamp. That is 10 times 10 raised to negative 3 amps. So this is the current that will flow through the circuit. The same thing, the same current. How about the voltage? The total voltage in the circuit, for this particular circuit, Vt is equal to what? 5 volts. We want a galvanometer that will read up to 5 volts, exactly what I'm holding in my hand here. That is it. So the voltage is 5 volts. So we say that Vt is equal to Vm plus what? Vg. That is the voltage in the circuit. So if we do that, we want to find Rm. We are looking for Rm. Rm is nothing. What is the value for this resistance? So right, from Ohm's law, from this equation, call this equation number 1, equation number 2, equation number 3. Equation number 2, equation number 3. So we are going to customize equation number 1 by saying that Vs is equals to, Vm, we're looking for Vm. Vm is equals to Im Rm. Call this equation number 4. So if we do that correctly, we are going to make Rm the subject of the formula. So we'll have Rm is equals to Vm divided by Im. Yes, Vm divided by Im. But what is Vm? What is Vm? This implies that Vm from here is equal to Vt minus Vg. Vm is equal to what? Vt minus Vg. Vt is the total voltage in the circuit is 5 volts. It's 5 volts. So but Vg is equal to what? You know from Ohm's law from here, V is equal to IR. Vg is equal to what? Ig times what? Rg. Meaning if you substitute in the values for Vg, Ig is what? 10 times 10 raised to negative 3. Rg is 100. If you do that, you're going to have 1 volt. So our Vg is what? 1 volt. So we are going to substitute the whole of this here. So we are good. So write that our Vm from that equation, which is given as our Rm from that equation, which is given as Vm over Im. This implies that Rm is equal to, we agree that our Vm is Vt minus Vg, so we write Vt minus Vg divided by Im. Recall that IT is equal to IM is equal to IG equals to R equals to what? 10 times 10 raised to power negative 3. So this implies that Rm is equals to 5 volts minus 1 volt divided by 1, 10 times 10 raised to negative 3. If you do that, you'll be having 4 volts divided by 10 times 10 raised to negative 3. If you evaluate correctly, you are going to have 400 volts. Yeah, that's correct. 400 ohms. 400 ohms. So therefore, the value for this resistance Rm now converts the galvanometer to read up to what I'm holding in my hand here is given as 400 ohm. This is the value. Remember in the definition we said that a very high resistance wire. So we are going to solve for Rs now. We're going to solve for Rs now. In solving for this, I'm going to clean this and draw a circuit diagram for Rs so that we don't get confused. Okay, if you want to convert a galvanometer into an ammeter that will read up to 10 amps, you need to connect the galvanometer in parallel with a very low resistance wire called a shunt. How do you do that? So this is the shunt, and this is the galvanometer. This is the galvanometer. We extend this wire, we extend it this way, then bring it down here. Bring it down here. So we can call this our terminal A and call this our terminal B. And this is the resistance for the shunt, and this is the internal resistance for the galvanometer. This is the current IT. Let me write it down. The total current IT entering here. Sorry, that is the alarm for school. Sorry about that. That was the afternoon prayer in the school I teach. 12 o'clock. Good afternoon. So back to business. This is what I'm trying to say. That here you have two currents. One current is entering here. This current, this is the total current, and the total current here is what? This current is IT, is given as what? 10 amps. This 10 amps is entering in here. And then because these guys are in parallel, you're going to have different current flowing through them. So the current entering into the galvanometer is IG. And what current is that? The current is what? 10 milliamps. So the current entering into the galvanometer is what? 10 milliamps. How about the resistance for the galvanometer? The resistance for the galvanometer is what? 100 ohm. Look at it here. So we are good with that. So up here is the arrow, the current entering into the shunt, Is, which we don't know. And here this is the voltage across the shunt, and here is the voltage across the galvanometer. Now, interestingly, because these guys are in parallel, you're going to have the same voltage across each of them. So we write that Vt is equal to what? Vg is equal to what? Vs. Let me rewrite. Vt is equal to what? Vg is equal to what? Vs. Yes. The only voltage, the only parameters that are given here that are complete. So if you want to find the total voltage in the circuit, we are going to use the information for the galvanometer which is given here. So let's find VT in the circuit. So this implies that we're going to pick we are going to pick this from Ohm's law. We know that V is equals to IR from Ohm's law. So we want to customize the equation for VG. So this implies that our VG is equals to IG times what? RG. If we do that, we're going to have something like this. This is the same thing as what? 10 times 10 raised to the power 3, negative 3. That is VG, milliamps times what? 100 watts ohm. If we do that, the voltage across the galvanometer, we're going to have 1 volt. Let me verify 1 volt. So we have 10 times 10 raised to negative 3 times 100, negative 3. 10 times 10 raised to negative 3, 100 times 10 exponential negative 3. 1 volt, I was correct. So the voltage across the galvanometer is 1 volt. So what we are saying here is that Vt is equal to Vg is equal to Vs, and this is the same as what? 1 volt. The total voltage in this particular circuit is 1 volt. Take notes. Now, so Vs2 is also 1 volt. The voltage across the shunt is 1 volt. Across this is 1 volt. Entering is 1 volt. I believe that is established. So right now from Ohm's law, we are going to generate or customize the equation for Rs. Just as I did here, Vg is equal to Ig times what? Ig times Rg. We are going to do the same thing for Rs. So this implies that Vs is equal to what? It equals to Is times what? Rs. We want to make Rs the subject of the formula. So this implies that our Rs is equal to what? Vs. We divide both sides. V equals to IR. So Vs equals to Is times. So Rs is V divided by what? By Is. That's it. Rs is V divided by Is. So, but Is is not given. How can we find the value of Is? From this circuit, the total current flowing through the circuit, which is IT, is given as what? IT is given as Is plus what? Ig. IT is given Is plus Ig. So our Is is going to be IT minus Ig. So write that Is is equal to what? Is is equal to IT minus what? Ig. What is IT? Ig is 10 ohm. 10 amps in the circuit. So this is the same thing as what? 10 amps minus. What is Ig? Ig is given as 10 milliamps minus what? 10 milliamps. This is the same thing as what? 10 amps minus 10 times 10 raised to negative 3. If we do that correctly, we are going to have, that is a 10 minus 10 exponential negative 3. If we do that, we're going to have 9.99 amps. So our Is is equal to what? The current entering into the multiplier, the shunt, is given as 9.99 amps. That's it. So we come back to this particular equation. We come back to this equation and then we find the Rs. So this implies that Rs is given as Vs over what? Is. And our Vs is what? Our Vs is 1 volt. So what do we have? We have 1 volt divided by what? Divide by what? 9.99. If we do that correctly, what do we have? We have 1 divided by 9.99. Our RS is giving us 0.1001001 ohm. That's it. Therefore, RS is equal to this. Can you see how lovely this is? I told you that the shunt is a very, very low resistance wire, and you can see that reflecting in the question. Quickly, before I end this video, let's look at question number 19. I mean, it's well explained. Yes, it is. So let's look at question number 19. Question number 19 reads, a galvanometer resistance 50 ohm, which gives a full scale deflection for 1 milliamps, is to be adapted to measure currents of up to 5 amps. I. Calculate the resistance of the resistor required. II. If this resistor is made of a material of cross-sectional area 4 exponential negative 4 cm squared, and resistivity of 2 exponential negative 6 ohm centimeter, calculate its length. Very simple. So this is question number 19. Question number 19. Let's collect our data and also the sketch of the diagram. The sketch for the question. So as usual, the internal resistance for the galvanometer Rg is given to be what? In this case, 50 ohms. 50 ohms, which gives a full scale deflection when the current of what? Current in the galvanometer of 1 milliamps, meaning 1 times 10 raised to negative 3 amps was passed through it. So we are asked to calculate the value for the shunt, that is RS. For the shunt is not given. So quickly, and then this is I, the value for the shunt that will help read, the value for the shunt that will help read an ammeter up towards 5 amps. The value for the shunt that will convert it into an ammeter that will read up towards 5 amps is not given. So they ask us to calculate the length of the wire. The length of the wire. Without wasting much time, let's quickly look at this. The sketch for the diagram is simply this. We are going to connect the galvanometer in parallel with a shunt, a very low resistance wire. As I did in question number 18, we apply the same thing here. So this is the galvanometer. It will read this way. And this is this. It will read this way. This is terminal A, and this is terminal B. The current entering here, this is your I total, and this current is what? Your I total here, this current is what? Your I total is 5 amps. It's 5 amps. So the current entering here is the current in the galvanometer, which is what? 1 milliamps. The current in the shunt, IS, is not given. This is RS, resistance of the shunt, and this is what? RG, resistance of the galvanometer, which is what? Which is 50 ohm. The resistance for the shunt is not given. The current will come here, will pass here, will come down here, will go here, and then will pass out here. So what we are required to do is to generate the equation right now. So from here, the total current in the circuit is given as what? Is given as the current, that is Ig, the current entering into the galvanometer, which is 1 milliamp, Ig plus what? Plus Is. So our Is in this case is what? Our Is here is given as It minus Ig. What's the meaning of that? Meaning 5 amps minus 1 times 10 raised to negative 3 negative 3 amps. If you do that correctly, what do you have? We have 5 minus 1. We have 5. We have 1 times 10 raised to negative 3. The answer is that. So we have 5 minus that answer. The value for this current is given as 4.999 amps. So our Is, the current entering to the shunt, is given as 4.99 amps. That is the current. So from Ohm's law, we know that V is equals to IR. And because these guys are in parallel, we are going to have the same voltage across. This is the voltage across the shunt, and this is the voltage across the galvanometer. We are going to have the same voltage across. So we say that our VT is equals to VG is equals to what? VS is equals to VS. So we are going to use the information given for the galvanometer to find the total currents that will flow through each of the parameters of the circuit. So we have from VG, we have VG is equals to what? IG times what? RG. To do that, our IG is 1 times 10 raised to negative 3 times what? 50 ohm. If you do that correctly, you have 1 exponential negative 3 times 50. If you do that, we have 0.05 volts. So this is the total current of voltage. So what we have VT is equal to VG minus VT equals to VG equals to what? VS equals to what? 0.05 volts. That's the current of flow through all the circuits. So right now from VS is equals to IS RS. We are going to make RS so the formula, so we have our RS is equals to VS divided by IS. RS equals to VS divided by RS. So if we do that, we're going to have 0.05 divided by our IS was given as 4.999. So we write 4.999. If we do that, we are going to have the following. So we have 0.05 divided by 4.999. If we do that, we are going to have the result as 0.010002 ohm. Yes, this is it. This is the equation for that. So the last question I will give as a challenge is given as the resistance of a wire is directly proportional to the area and inversely proportional to the length. Yes. Sorry. It's proportional to the length and inversely proportional to the area. So our R is given as rho L all over A. This is the equation you need to solve the other question. To this, we have come to the end of this particular video. This is the question you need to solve. You need for the other information provided in the question. To this, we have come to the end of this particular video. Don't forget to subscribe to my channel and share this with those that need it. God bless you. Bye bye.